Okay, in this video, we're going to do a quick how-to and then a couple of examples on the derivatives of inverses for an introductory calculus class. So how will you know you're going to use the derivatives of inverses? Well, if your question gives you some notation that tells you have an inverse, so f of g of x, g of f of x, that they're equal to each other, which are equal to x, they cancel each other out essentially. I know that f and g are inverses. Or we could be a little bit more explicit. G is the inverse of x, where this notation refers to the inverse of f. So g is the inverse of f. Or we could also have it written in words. G is the inverse of f. Okay. Then to solve these, you need to identify the AB coordinate pair, right? Some x value and some y value. We'll call it AB, such that f of A is equal to B and g of B is equal to A. That's the relationship between inverses, right? That relationship is that AB maps to BA on the inverse. But here's the important piece. Once you have identified that coordinate pair, then g prime of B is going to be 1 over f prime of A. Okay. In other videos, you can go and see why that relationship is, but right now, for this purposes, can you use the relationship? So let's look at an example. So f of x is 2x plus 1 to the third power, and g is the inverse. F of 0 is 1. What is the value of the derivative of g at 1? So in other words, what is, right, and this notation makes it look a little bit stranger, right? This notation makes it look a little bit stranger, that we'd be saying, hey, I want the value of the derivative of the inverse of x at x equals 1. Well, much easier to just write g prime of 1. So we know f of 0 is 1. That means g of 1 is 1 over f prime of 0. That's our relationship. G prime of b is 1 over f prime of a. So 1 is related to 0. So if I want the derivative of the inverse at 1, it's going to be 1 over my function at 0, the derivative of my function at 0. So using the chain rule, f prime of x is going to be 3 times 2x plus 1 to the second power times, right, the derivative of 2x plus 1, which is really just 3 times 2x plus 1 to the second power times 2. So if I substitute in 0, that's going to be 3 times 1 squared times 2, which is 6. So g prime of 1, which is 1 over f prime of 0, is 1/6. Okay. Now, let's look at another example so we can kind of understand that process again. Okay. So here we have functions f and g are differentiable. For all x, f of x equals x and g of f of x equals x. So this is telling me that g is the inverse of f, or f is the inverse of g. So f of 3 is equal to 8. So that's our pairing, 3 and 8. Right, f prime of 3 is equal to 9. We don't really care about this as much. We care about this pairing, 3 with 8. So what is g of 8 and g prime of 8? Notice that it has to be the 8 that we're evaluating. So since we're given that f of g of x is g of f of x, which is x, we're working with inverses. F of 3 is equal to 8. We know that g prime of 8 is that reciprocal of f prime of 3. F prime of 3 is 9, so that means that g prime of 8 is 1/9. And of course, switching x and y, I have g of 8 is 3, because if I know I have the coordinate 0.38 on my function, that maps to a coordinate of 8,3 on my inverse. And it is very important to understand the relationship there. Okay. In our next videos, we'll look at a few examples. Thank you for your time.